This is Stephanie from statisticsHowto.com. The statistical power of a study is how likely the study is to distinguish an actual effect from one of chance. It's the likelihood that the test is correctly rejecting the null hypothesis, in other words, proving your hypothesis. For example, a study that has an 80% power means the study has an 80% chance of the test having significant results. A high statistical power means the test results are likely valid. As the power increases, the probability of making a type 2 error decreases. A low statistical power means the test results are questionable. Power helps you to determine if your sample size is large enough. It is possible to perform a hypothesis test without calculating the power. If your sample size is too small, your results may be inconclusive when they may have been conclusive if you'd have had a large enough sample. Here's the relationship between power and beta. A type 1 error is the incorrect rejection of a true null hypothesis. Alpha is the size of the test. A type 2 error is where you don't reject a false null hypothesis. This is the beta. Beta is the probability that you won't reject the null hypothesis when it is false. So the statistical power is the complement of this probability, 1 minus beta. Power is quite complex to calculate by hand, and you'll normally want to use software to calculate it. For example, in SAS, PSS provides power and sample size for a wide variety of statistical analyses. The exact calculations depend on what test you're running. For example, the power calculation would be different if you were comparing a proportion to a specified value than if you were running, say, a paired t-test. Power analysis is a way to find power. As a simple example, let's say you are conducting a drug trial and you found the drug works. You run a series of trials with the effective drug and a placebo. If you had a power of 0.9, that means 90% of the time you would get a significant result. In 10% of the cases, your results would not be significant. The power in this case tells you the probability of finding a difference between the two means, which is 90%. But 10% of the time, you wouldn't find a difference. You can run a power analysis for many reasons, including to find the number of trials needed to get an effect of a certain size. This is probably the most common use of power analysis. It tells you how many trials you need to do to avoid incorrectly rejecting the null hypothesis. To find the power given an effect size and the number of trials available. This is often useful when you have a limited budget, say 100 trials, and you want to know if that number of trials is going to detect an effect. Another reason is to validate your research. Conducting power analysis is, simply put, good science. That's an overview of power. Check us out at statisticsHowto.com, and I'll see you in the next video.